Hi guys, welcome back to my channel. Today we're going to talk about radioactive decay. All right, as you can see on our periodic table, we have 118 elements, but not all of them are stable. As you can see on this picture, we have the yellow highlighted ones that are called radioactive elements. And they are the elements that are unstable, that are most likely to go through radioactive decay, meaning that they can lose their energy through radiation, okay? All right, let's start with alpha decay. What is alpha decay? So alpha decay is basically an unstable atom emits an alpha particle, okay? And then this alpha particle has 2 protons with atomic mass 4, okay? So let's imagine it's nitrogen, which is not the case. Nitrogen is a stable atom, right? But let's just use it as an example. Let's say nitrogen has 7 protons, right? Because it has atomic number, its atomic number is 7, and then 14 is the atomic mass of nitrogen. Okay, so how do we subtract an alpha particle from nitrogen? And by the way, alpha particle is also called a helium, right? So I use the word subtraction, if you will, because literally the new atom that we are coming up with has 7 minus 2, 5 protons. And then the atomic mass will be 14 minus 4, 10, okay? So if I look at my periodic table, which atom has 5 protons? It is boron with the atomic number 5, right? Okay, so this is alpha decay, okay? So if you look at the periodic table, what I do is I don't wanna logic through this when I'm on my exam, so I just count 2 atoms backwards, okay? Meaning nitrogen is here, and then when I see alpha decay, and then I just count 1, 2, okay? Then I know the new atom is boron, okay? So if it was this complicated Hg atom, then on MCAT, you see alpha decay of Hg, then you say, okay, 1, 2, okay, Pt is the new atom, okay? All right, so this is alpha decay. And what else you need to know about alpha decay? It is that once this alpha particle gets absorbed or swallowed or inhaled by human, then it's more harmful than beta and gamma decay due to ionization, okay? Due to ionization, alpha particle is the most harmful one. But alpha decay is not that penetrate. It's not that penetrative, okay? So if you just emit an alpha particle towards me, it doesn't really penetrate my skin, okay? So it doesn't penetrate a piece of paper. So it would be fine if I don't inhale it, if I don't swallow it, okay? Whereas gamma is the most penetrative decay compared to beta and alpha, okay? I think that's the other thing you want to know about alpha decay. And then one more thing is alpha decay relatively shoots at low speed, whereas beta decay are at faster speed, okay? All right, now I think we can move on to beta minus, okay? There are 2 types of beta. Let me just first circle the particle that it emits. Okay, beta minus. Okay, so it's called beta minus because it emits a beta particle that has a minus charge, just like an electron, okay? And then due to its likeliness with electron, it has 0 atomic mass, okay? So let's still imagine it is nitrogen. But once again, in reality, on MCAT, you're unlikely to see nitrogen since nitrogen is not one of those unstable atoms, okay? But the idea is the same. The subtraction is the same, okay? All right, so now let's subtract, okay? So the new atom has 14 minus 0, 14 atomic mass. And then how many protons does it have? 7 minus 1. That gives us 8, okay? So I look at my periodic table. Which atom has 8 protons? Oxygen, right? Oxygen is the one that has atomic number 8, meaning 8 protons, okay? So on MCAT, I see an atom is going through beta minus, it's nitrogen, I just go 1 atom forward, it's oxygen, okay? So if it was this Hg again, then you beta minus, 1 atom forward, Ti, okay? All right, so this is beta minus, okay? So let me circle this beta particle that it emits, okay? You can also think it's an it is an electron, okay? So you might have also heard of something like, oh, beta minus converts neutron into a proton, okay? Let's write it out and rationalize it. Neutron to proton, okay? Why is this the case, okay? You can really think of neutron being proton plus electron, okay? Because neutron has 0 charge, proton has +1, electron has -1, okay? So +1 plus -1 equals 0, neutron, okay? So once I emit the electron, okay? Here, electron, I emit it. So what you're left off is a proton. So basically you turn neutron into a proton, okay? It also makes sense if you look at this nitrogen has 7 protons. But now I turn the neutron into proton, so I have 1 more proton. Yeah, oxygen has 1 more proton, right? And then also you can tell that I don't have the addition of any neutron or proton, right? Because atomic mass is really about the addition of neutron mass plus proton mass. But I'm not losing any neutron or proton, and I'm not having more. I just lost an electron. Okay, that's why my atomic number is constant. Sorry, my atomic mass is constant, 14 to 14. But my proton number increased 1 more. That's why I go to the periodic table, I move 1 atom forward, okay, to get my new atom that it becomes of after the emission of beta minus decay, okay? All right. Now let's move on to beta plus, okay? So beta plus decay also emits a beta particle. But the difference is this beta particle is not like electron. It's like anti-electron, which means it has +1 charge, okay? And then because of this change of electron, I mean, it doesn't affect my atomic mass, right? Okay. So it's nitrogen, 14,7. Okay, let me get rid of this. Let me subtract this beta plus thing, okay? What do I get? So 14 minus 0, I get 14. And then 7 minus +1 gives me 6. So it will be carbon, right? Okay, so this is the new atom that I come up with after beta plus decay, okay? And then you may also have heard of, oh, beta plus is going from proton to neutron, okay? Let's rationalize it. Proton to neutron, okay? Why do we say that, okay? Because proton, this positive thing, basically equals neutron plus anti-electron, right? All right, so proton is +1, neutron is 0, anti-electron is +1. So this makes perfect sense. So you know the beta particle that I emit is just an anti-electron thing that has a +1 charge, right? So once I get rid of this, I really turn the proton into the neutron, okay? And it makes sense if you look at the proton number. I have 7 protons here. Now I have 1 less proton because this proton is turning to neutron. So I have 6 protons. The new atom is carbon, okay? And then once again, I have no addition or subtraction of the number of my proton and neutron. So I have the constant atomic mass, which is 14, okay? All right, that is beta plus, and beta plus has another name called a positron decay, okay? So positron is also the name of this anti-electron, okay? You can call it plus beta or anti-electron or positron, it's up to you, but it's the same thing. The particle that carries +1 charge without any atomic mass, okay? So this is a beta plus, okay? Now let's move on to gamma. Gamma decay is really simple, okay? So because the gamma is not a particle, it's a photon. So it has 0 atomic mass and 0 number of proton, okay? So if I were to do the subtraction, I still have my nitrogen, okay? And then just to remind you, gamma is on the highest energy and the electromagnetic spectrum, right? It has the shortest wavelengths and then highest frequency, right? Okay, so this is gamma decay. All right, now let's talk about electron capture. Electron capture is basically me capturing an electron with the negative charge, okay? And then, as you know, if I lose an electron, means my atom really has one less proton as well, right? Because most of the time, the number of electron equals to the number of proton. So nitrogen is just really carbon 614, okay? This is the new atom I have after electron capture, okay? All right, and then you actually get some X-ray. And then it's also, there's this particle that particle makes up this X-ray. It has a terminology, it's called a neutrino, but I don't think you're really gonna see it on MCAT, but just so you know, okay? All right, so this is electron capture. All right, so once again, if I do it on MCAT, let's say my original, this is the atom that's going through any type of radioactive decay, okay? So I know if it's alpha decay, then I count 2 atoms backward, 1, 2, okay? I know HA is my new atom. And then if it's a beta minus, I count 1 atom forward, okay? Here, RG is the beta minus decay, okay? And then beta plus is counting 1 atom backward, okay? So if DS was the original atom, after beta plus decay, I have this MT as my new atom, okay? And then gamma is just the same, okay? And then electron capture is the same as beta plus, okay? So you go 1 atom backward. If it was DS that goes electron capture, you will get MT, okay? So that's all I want to discuss about radioactive decay. And then when I first learned this, you know how much I like coming up with charts, okay? This is a chart that I come up with. So you can take a screenshot or you can rewatch this video. And then if this doesn't make sense, you can really just memorize this chart and you will be gold on MCAT, okay? I hope that's helpful.